Hey guys, welcome back. Today in this video, we gonna work on Fibonacci number. This is the one lead code problem, problem number 509. It's categorized as an easy problem, and we want to know what is it and try to solve it. To do this, usually we can do by this approach. So first of all, we need to find what is the problem. Then we need to go over, markdown and write markdown for that. And markdown is inline comments for Swift. And also we gonna visualize the problem. Visualize the problem, and then we will go with some code, actually solution, and also for sure unit test, which is very important for any problem you solve. And at the end we will go for complexity. Okay, so to do this, I start from markdowns. So I say, okay, I'm gonna write my unit sample here, and then I'm gonna write my solution here, and I'm gonna write visualize here. Okay, let's start from solution. So solution, I put it in class solution, and inside this I need a function to solve the problem, but so here it's gonna be a function to do what? Okay, to do what? So here we need to read the problem actually. Right now we are here. Okay, so the Fibonacci number, commonly denoted Fn, from a sequence called Fibonacci sequence, such that each number is sum of the two preceding ones. So Fn, it's Fn minus 1 plus Fn minus 2. Starting from 0 and 1. So 0 and 1 is going to be F0 and F1, and then we will go for the rest. So this is going to be whole formula. The good thing is that this make it this easy because we have already formula for that. Okay, and given n, calculate Fn. Okay, so we give n, and we need to calculate Fibonacci number n. So we write a function to calculate Fibonacci number. Okay, so to write a function, first thing we will ask, okay, what are parameters? So as we learned here, it is we have only one parameter, which is n. So this n is an integer, type of integer. And okay, so the second question you will ask is what is the range for n? So here we need to mention what is the range of one. You will ask from your interviewer, or usually you will find. So here you will see that it is between 0 and 30. Okay, so this is gonna be range for that. Then here we can write description, but usually interview, to save time, you skip that. So then we need to mention time complexity and a space. complexity. We don't know what are they, and we will figure it out when we've done our coding. Now we need to also clear what is our return. So our function gonna return Fibonacci number, so it's gonna be integer as well. So it's gonna be integer, which is the Fibonacci number. Yeah. So this is going to be our function, actually our markdown for a function. So now we can write our function easily. So for function, we need to choose a name. So name it as a fib, for example. And then for function, what are the parameter? It's going to be n. Here we mention it is n, okay, and type integer. Okay, so now we need to say what we return. So we return an integer as well, yeah? So this is going to be our main function, but. Okay, so to solve this, now we need to go for visualize to find the solution. So I start from example number 1. Okay. So if I want to visualize example number 1, what I say? I say, okay, we say if, actually the good thing is that we have a formula, so we don't need to do too much, so we just put it there. So we know that f1 is 0, and f0 is 0, and f1 is, we know this, yeah? So this is the start point for Fibonacci number. And now we need to calculate f2. Actually number is 2, so f2 is going to be f2 minus 1 plus f2 minus 2, which gonna be 1 plus 0, and it's gonna be 1. Yeah. So this is not big deal. Also, for example, actually this was example number 1, example number 2. It's gonna make it 3 and then 4. So let's put these two examples here and comment them. Oops. And so technically it's gonna be same as this for a start. Then we need f number 3, which gonna be f2 plus f1, which gonna be 1 plus 1, which is 2. Yeah. Okay, so this is not big deal so far, but we can calculate it in here as like this, but we need to find the formula. So actually we need to find the solution for that. So Fibonacci, if we want to approach to solve this problem, we can start from recursive, or we can go by brute force. But those are the first approach, but we need to make it a little bit more optimal to make our time complexity and even space complexity better. So to do this, I want to introduce a approach by the name of dynamic programming. So in dynamic programming, so for Fibonacci number, so I'm going to write later. So in dynamic programming, what we do? First, we do it in 5 steps. So first we say, okay, we need to recognize our sub-problems, so sub-problems. So our sub-problem is this, yes? No, this is not sub-problem. Our sub-problem is if I say, okay, if is f k times, so gonna be, sub-problem name gonna be fk or fn, we say, so gonna be fk, and while k is start from 1 and end with n. So this is important. Our our k start from 1, which is f1, and end with n. So this tell us that number of the sub-problems. So in the first step, we will find what is the number of sub-problems. So number of sub-probs are n, because we start from 1 to n. Okay. Step number 2. So step number 2, then now it's time to usually guess. So what means from guess? So usually now we don't need to guess because we have formula. But sometimes we don't have formula, so we need to guess how we can do one subproblem, and then from that subproblem recursively we get to the results. So right now we're not gonna do any guess, but later in other problem you will see that we will guess. So so number of any subproblem is 1. Okay, so and third step. In third step, we come for subproblem solution. So subprobs this is usually our most difficult part. So but here for Fibonacci is easy. We can say fk equal fk minus 9 plus fk. This is the our subproblem, and now we need to find, okay, how many times. So it's going to be time divide by subprobs. So it's going to be k, which is n, and subprobs n, so it's going to be 01 for each subproblem time. We need usually it's going to be 01 for each subproblem, and then we will go for number 4, which is our choice to do recurse or bottom up or top up. So bottom up or top order. So it means that we can do recursive, or we can start for loop and iterate for this from 1 to n, or we can do by recurse. So we're gonna solve this by both. So then by this way we can say our total time equal time divided by subproblem, which was O1, okay, multiple subproblem. So it's gonna be this guy multiple this guy. So O1 multiple n, which gonna be O n. So time we need to solve this problem gonna be O n. But also we need to do two check here. If we go by recursive, we should make sure that it's not gonna also, we need to check that it's not, actually it is a cyclic, means that our graph for this should be acyclic. I'll go over that and show you. Other than, and if it's go by bottom up or top order, we need to make sure it is topological order. To understand these two, I will make a video and we can go over them. Okay, so let's go for the final. Actually, for this one, let me show you, what I mean. So usually we have one decision tree or graph or whatever. So here start from what? It is start from F1, actually F0, and then from F0 actually yes, it starts from F1 because we're not gonna, yes, and then from this we gonna calculate then it's gonna be F2 and F3. So for calculating F2, what we need? We need to have actually sorry, it's we can go by Fn. So then we need Fn minus 1 and Fn minus 2. Yeah, this is, I think this gonna be better visualize. This could be part of the visualize as well. So here it's gonna be F for Fn, then we need Fn minus 1 minus 1. So Fn actually minus 2 and Fn minus 3, also minus 3 and minus 4, and we can continue until as much as we need. So now let me put this here and put this here. Even if you want to make it better, we can make it like this. So now you will see. Now when I want to calculate Fn, I need to calculate this tree or this recursive. So you will see Fn minus 2 is here. So if I calculate Fn minus 2 here, then I don't need to calculate Fn minus 3 and 4. So So if I calculate this, then I don't need to calculate the rest. So it's gonna, by this way we can save. So I will show you how we can save later. So, and also here you will see that it is not it is a secret. Okay, and finally in the final portion, we will go for original problem. So we solve our small problem, but our original problem, which is fn, we need to solve it, and we need to see, okay, for solving an original problem, how much we need. So extra time we need just 01, so it's not too much. So again, in comparison of n, it's going to be 01. So this is going to be how we can find complexity. Now we have our decision tree like this. We have this formula, and we want to solve this. I'm gonna solve this problem in two ways. First of all, I'll go by recursive, and then I'll go by bottom up or top order iterative between the 1 to n. So for recursive, usually we will have one main body, main function, and we will have one sub function. So I'm gonna write my sub function. It's gonna be same name as main function. It's just different signature. So if we can do that, so I'll do it. So here I just pass in from type of integer. Also I'm gonna add memo. So here I told you, if when we calculate this, or when we calculate fn minus 2 once, then we don't need to calculate this. So when here we're gonna eliminate this part of 3, so save time. So we use memo. This is that's why dynamic programming approach help us to save make our complexity more efficient. So I'm gonna pass one memo here, okay, and then this memo gonna be array of integer, which gonna be my f n minus 2, f n minus 3, and whatever. So it is an array of integer, and that's it. So I'm gonna this function gonna return one integer as well. But what happened? This memo gonna be in and out. What that means? It means that I'm gonna change it inside my function. Okay, so first of all, when we write one recursive function, we need to make sure write base case, which avoid, as I told you, avoid to make it be a loop. Okay, base case. So base case gonna be if range of 0 to 1 so if n is in this range, or this range contains n, what I want to do, I want to return n, because we know that f0 is 0 and f1 is 1. Okay, so this is gonna be my best case, and then I'm gonna say, okay, if my memo n equal 0, if this one was 0, what I want to do, I want to say memo n equal fib n minus 1 and at sign memo, okay, plus fib n minus 2 and memo. So memo n is 0, so what happened? This gonna between I'm gonna add fib. I'm gonna say okay, memo n equal if sorry, you know what I'm saying, making here. So say if memo n is 0 and is not exist, I'm gonna create it, which is fib n minus 1 and memo plus fib n minus 2 and memo. Actually, this and means I pass this memo to my fib, to my recursive one. So, recursively, it keep calculating. And here I just say, okay, return n. Okay, so this is how we can start to make. So if we put number here, you will see if I start put number 2, then it's gonna be calculated. And okay, so in my main one, I just say variable memo equal array. So this array, how may I make it? I say okay, repeat value 0. So I put 0 in all of my memo in count of n plus 1. So one bigger than my n. And here I just say okay, for me start to calculate return fib n and memo. This @ sign is because I use in and out here. So when one one parameter is in and out, you need to put this before that when you call it. Then Swift knows that this is an array. Okay, so let's see. Let's run this and see if it's work or not. So get some error. What is the error? It said in out. Maybe here I should put some space. Yes, but still there is some other issue. Okay, let's see what is this. It's all about the spacing. Int memo in out integer return int. So line 28 must be separate. This is not correct, guys. After this, yeah, space here. Yeah, but answer is wrong. We expect 1, but answer is 2. So what's happened? N minus 1 and n minus 2. Maybe here I need to put some space. I don't think so, but let's try it. Oh, here I just return n. That's my mistake. So I should return memo. Yes, I return memo n. Here we go. So we wrote this by Recursive and it's working. So what I do, I'm gonna write one test case for that as well. So my test case, I just say function test example 1, for example, and this one, and here I'm gonna call this test example to make sure it's working. And actually it's called, so I just say okay, an object equal solution. Then also I just say okay, let if n equal 4, what I expect to be output. So output base of this example should be 3. Output should be 3. Now I write okay, assert my object dot fib n should be equal output. Okay, other than that I want this message failed example number 1. So let's run now again. Yeah, we are good. So even we can submit it to see. Yeah, it's very good, 100% faster than others. Okay, perfect. So we wrote this in recursive, but I want to write one iterative solution as well. So let's go. I make a copy of this and I put this here, and here I just I'm gonna remove this second function, and I am gonna what I'm going to do, let me delete inside this as well. So also about the complexity, we calculate complexity. Let's see, as we calculate our complexity gonna be O n, and our space complexity is O n as well, because we got this memo with length of n. Okay, so and our approach here is DP recursive. Okay, so after recursive approach, I want to write another approach which is DP dynamic programming top down memorize, because memoization. Okay, so let me make this one like this. Also this is memorize as well. It's not memorize, we say memorize in dynamic. This is what they named it. Okay, so for iterate, how we can do a iterative approach? It should be the same, actually, top down. So it should be almost same. So what I'm gonna do, first of all, I'm gonna write my base case. So my base case gonna be same. Then I need to start, I make, okay, variable prev1. So prev1 is gonna be 0, and prev2 gonna be 1, and I start one for loop broadcast. I don't want to pick up index, so in 2, in range of 2, and n, but not including n. My new fib number is prev1 plus prev2, prev1 equal prev2, and prev2 equal new fib number. And here I return prev2 plus prev1. So now we need to check it out. So it's fib, I make it fib1, and here in my test I'm gonna call it. Let's run. It is working, and it's working fine. So just about the complexity, it's gonna be on because n times, but our space complexity gonna be o1 because we didn't get any extra memory. We just calculated in iteration, and we do it right away. So yeah, that's it. We calculate Fibonacci number in two way of iterative and recursive. Please, if you like this video, make sure to give it thumbs up, and don't forget to be subscribed and follow us for other video which are coming every week. Have a good one. Bye.